Okay, so we're going to be talking about evaluating a root, and I'm just going to stick with monomials for the moment. So once again, we're going to talk about. I'm going to stick with square roots. This, remember that our symbol here is our radical. The expression under that is our radicand. And say I've got something like 50x to the sixth. When we're doing this, what we're going to do is we're going to factor the radicand. Then we're going to split into two radicals. One with our perfect powers, and one with our remaining factors. So here with 50, if I were to break this up, I can see that, hey, 25 is a perfect square. I could in fact do that. Or I could say this is, 5 times 5, this is 5 squared. So this is 2 times 5 squared. X to the 6th, oh, that's definitely a perfect square. So this would be x cubed times x cubed. So when I'm thinking about this, this is just our little thought bubble here. This is our thought process. When I'm thinking about this, I'm going to break this up into two different radicals. I'm going to put my perfect powers, like that 5 squared, under here. And I'll put that x to the 6th under here. And our remaining thing, 5 squared times 2, was our 50. So if I were to multiply these out, I would be right back where we started. But now that we split this into two radicals, now we're going to evaluate the perfect power radical. So here, square root of 5 squared is just 5. Square root of x to the 6th is just x cubed. And I still have this square root of 2. So I'll be done with that one. Now, notice that what we're essentially doing, since this is the square root, what's essentially happening here is we are dividing all of these powers by the index of the radical. So thinking about this, this is a little bit like saying, oh, this is going to be, square root of this. And I'm actually writing the 2 there. It's not usually written on the square root, but it is implied. This is, 5 to the 2 over 2, and then x to the 6 over 2. This is 5 to the 1st, x to the 3rd. So we're just dividing these powers by the index of the radical. In this case, it's a square root, so so my index is 2. If I were to do this with a cube root, I would be dividing these powers by 3. But let's do another one. Let's do one that looks a little different. How about I do something like, I'm going to do the square root of 49 x squared y z to the 7th. Now this one is 49, that's hopefully fairly easy to spot that 49 is 7 squared. So this is going to be, I'll have that 49 under that first radical. I can also see that x is a perfect square. I can pretty easily see that y is not a perfect square. But then we've got this z to the 7th. And what we're going to do here is we need to ask ourselves, what's the biggest multiple of 2 less than 7? And the reason why I'm doing that is I'm trying to break this up into a perfect power and not a perfect power, our leftover power, our remaining power. So our biggest power that's a multiple of 2 that's less than 7 is 6. So I'll have z to the 6th times z, which means that under this first radical, I'll have z to the 6th. Under the second one, I'll just have that z. So now I will have, that'll be 7x z cubed, and this is still times that square root of yz. Once I've evaluated that square root, that radical goes away. We don't write that radical anymore. But yeah, we're done right there. If I were to do this with cube roots, same sort of process applies. So say I had something like, say I have 250 x squared, I'm going to do the cube root, x squared y cubed z to the 5th. All right, this one's going to be a little trickier. We've got a cube root. So let's figure out, first of all, what all of our things are. I see 25 and I say, I see, that's 25 times 10. 25 is 5 times 5. 10 is 5 times 2. So this is 5 cubed times 2. X squared, this is a smaller power than my index. So when I look at this, I'm going to say, 250. Let's look at my perfect powers and my leftovers. My perfect powers, I've got that 5 cubed. My remaining factor is going to be 2. X squared, that's a smaller power than my index. So that's going to be in this one. Y cubed, that's the same power as my index. So y cubed. That z to the 5th. Z to the 5th, my perfect power here is going to be just a cube, and then I'll have a remaining power of 2. So this is going to be z cubed, and I'll have that z squared here. So if I were to multiply these two together, so this is our check. If I were to multiply these two together, I would be right back where we started. And everything in this first radical, I can evaluate. So the cube root of 5 cubed is just 5. This is going to be 5yz times the cube root of 2x squared z squared. Alrighty, hopefully this has helped, and I will see you in the next video.